Welcome everyone to this wonderful event, the Amazon as a Bioeconomy Superpower, which we're thrilled to be doing as part of the Science Summit here in New York today. I'm Lauren Barreto. I'm Chief of Staff at the Sustainable Development Solutions Network, and it's my great honor and pleasure to be your moderator today. We're going to start with some opening remarks from Ms. Emma Torres. She's Vice President for the Americas and head of the New York office at the Sustainable Development Solutions Network here in New York. And she's also one of the main leaders and brains behind the science panel for the Amazon.
Thank you, Lauren, and thank you all for coming. It's very exciting to be with you here in the Science Summit. It is also, as you know, the General Assembly decided that this should be a very important feature, science for policy making, science for decision making. So we're very proud of the Science Panel for the Amazon. Over 240 scientists have volunteered to work in producing the first assessment of the whole basin, which is a fantastic encyclopedia of what is the Amazon today. I think yesterday we had a very good panel, also from members of the Science Panel of the Amazon, where they elaborated a lot about the fact that the Amazon is a biodiversity superpower in the world, but also is major for global climate stability, major for carbon storage and water cycles. So it's really a major global asset, but it's under threat. And they elaborated a lot about the threats that the Amazon is having, including some potential risks of tipping points in some areas. But very important too, the panel focused on the possibilities, on the opportunities, on the potential for solutions. The Amazon is large and encompasses half of the continent of South America. So there has to be a potential for the Amazon to be an engine of growth and well-being for the region. The Amazon is also home to many groups of indigenous peoples communities which have lived in the Amazon for millennia, and they know how to manage the resources. So this is another big asset of the Amazon. So I'm very thrilled that today you will be hearing from members of the panel on not only that the Amazon is a biodiversity superpower, but it could become a bioeconomy superpower and lead and be an engine of growth and sustainability for the region. This requires a lot of investment, a lot of investment in innovation, mobilization of people, and I think this is one of the key messages of this panel, and they have worked pretty much along those lines when they were dealing with the third section of the report, which is solutions. And I think in the future, we're going to invest much more on that. This is a message for policymakers, investors, private sector. So I'm very happy also that Val is joining us, because we need to mobilize the private sector in all these efforts to make sure that we conserve the Amazon, but it also is an engine of growth and of sustainable development. Thank you very much for joining. Thank you for all that are joining from different parts of the world, and welcome to this interesting session. Thank you very much. Lauren, to you.
Thank you so much, Emma. So our first speaker is Liliana Dávalos, right here to my left. She's a professor of conservation biology at Stony Brook University here in New York State. And she's our first presenter. The floor is yours.
All right, let's try the clicker. Wow, things are starting. It's off to a great start. All right, well, thank you. I'm really honored to be here in the science, as a member of the Science Panel for the Amazon, and to also be able to share some of my thoughts about what is the potential for genomics to bring about a new bioeconomy, and what does that mean for conservation, especially how can we get the power of genomics to actually do something for conservation. So I'm going to first talk about how to translate genomics into conservation, or what we think, and the redistribution of benefits that is part of the Convention on Biological Diversity. So many people in the audience are going to know that the Convention on Biological Diversity, one of the key components of it was this access to genetic resources and benefit sharing, right? And the model for the access to genetic resources and benefit sharing has been, since the 1990s, at the center of the convention as a tool and as a mechanism that's going to bring about some kind of return on investment that's going to enable that. The latest iteration of this is actually the Nagoya Protocol, which hasn't been ratified and approved by all the countries, and which is preceded by the Cartagena Protocol and is preceded by Article 15 of the Convention on Biological Diversity. So what does it mean? At the time that this was first formulated and instigated, the idea that we had about the connection between genomics and conservation, or the access to genetic resources and benefit sharing, actually was something like this, something out of the 1990s. So this is from a movie. I don't know if anybody's old enough here to have watched this movie, The Medicine Man. In this movie, Sean Connery goes into the Amazon jungle and discovers cures. He's got like a bush lab. And in this bush lab, he's trying different cures, looking for cures for cancer, and he discovers something until the dean comes down. The dean is at CUNY here in New York. And the dean flies down to the Amazon and says, what have you been doing with the money? And do you really have a cure? And then the piece of forest that he found, this cure for cancer, is chopped down, and it's all very tragic in this movie. So what's the idea behind it? If we kind of take this apart, this movie, what it's really saying is that there are going to be some compounds out there, and they're going to have a genetic basis, and this genetic basis somehow generating some kind of market, and that market value is going to return. But let's see how it played out, okay? So this is back from the 1990s. So the way that it played out is that, okay, let's go back. So some countries actually invested heavily in them. One of the countries in the world that is a mega diverse country and invested very heavily was actually Costa Rica. And Costa Rica did that through INBio. And INBio had this trust fund that was devoted to bioprospecting, using bioprospecting in genetics, that was funded very well at the beginning. But by 2015, they were having trouble, right? By 2015, they were having economic trouble. They could not make it sustainable. And then a couple of years later, they actually crumbled. Their collections had to be sent to other research institutions around the country, and INBio doesn't exist in its formulation. So this makes me think, well, okay, this is kind of, like how is it that a mega diverse country like Costa Rica that invested heavily in genetic resources, in bioprospecting internally, did not succeed? If Costa Rica cannot do it, then who can do it? And so I'm going to bring some thoughts as to where we are right now in genomics, and that way we can think about where we need to be. So I'm going to start with a thought experiment, and I'm going to tell you what the thought experiment is in a little bit, okay? So this is a story from 2020 about the spike protein. And of course, the spike protein is super famous right now, because the spike protein is part, right? The spike protein is one of the key genes that is present in the coronavirus that has created all this economic chaos around the world, and therefore has a huge value to know what is in the spike protein. So let's read that little paragraph again, because I didn't read it because it's not in front of me, and it's also, okay. So let's kind of look at this paragraph with a little more focus, right? On January 13 of 2020, after Chinese researchers first made public the full RNA sequence of SARS-CoV-2, so on January 13, this is 2 weeks into 2020, the genomic sequence is already known. NIAID immunologist Barney Graham, so somebody from a National Institutes of Health, which is another public entity, and Moderna optimized version of the gene that would become the backbone of one of the two mRNA vaccines, okay? So what I'm highlighting there is that we have these two public entities, one in China that produced the first genomic sequence, and another one in the United States that already had this background knowledge from years and years of investment in something that was completely unprofitable and useless, which was the optimization of a vaccine for a disease that had been contained, SARS-CoV-2, right? So the optimization of a spike protein came from that. So the genomes are public, and it's a public effort, and then something happens. So the vaccines, by March of 2020, clinical trials were already almost completed for some of these vaccines, which is ridiculously hard. Some vaccines for most diseases, for some diseases, took 100 years to complete. So we're talking about 3 months. This is top speed. This is completely unprecedented. The mRNA vaccines are miracles of modern science. But there's a but. There's an issue. What's the issue? That whereas the knowledge that got us there is public, the actual physical vaccines, the product that came out, is not public. It is private. It's privatized, and it's so much so that the patents have been the subject of a call to try to release the patent somehow, a call to do something. Moreover, there's even a fight. There's a fight between Moderna and the National Institutes of Health in the US. Right now, there's a fight, legal fights between Moderna and Pfizer. right? So we have this process of privatization that happened, and not only is it a process of privatization, but also there's legal wrangling around it. So the thought experiment is, what if that beginning step was not public? What if that beginning step was privatized, right? And what that means. So let's get back to wildlife. Let's get away from those viruses and all that big money that's come out from vaccination processes and to things that are more familiar to us, biologists working in the Amazon. So I'm part of an effort that's called BAT1K, and the goal of our consortium is to actually sequence the genomes of 1,400 species of bats that are present throughout the world. But I'm not alone in this. There's a whole effort afoot with networks throughout the world that are seeking to sequence every single genome of everything that is living on this planet right now, right? And the vision behind that is called the Earth-Bound Genome Project. So I want to propose that these genomes have become a frontier. They're a resource frontier. And what I mean by frontier is that boundary between the public, common pool resources, and the private, right? When they become. So they're kind of like right there in this border. The genome publication is generating benefits, but the people who are best poised to reap those benefits are not actually the people that are conserving the biodiversity. Not yet anyways. So how do we ensure that benefits actually return to the countries, particularly now that we have CRISPR-Cas, and we can use genomic manipulation to transform and change the way organisms behave? How do we use that to promote conservation and to avoid extractivism? Yesterday we had some wonderful presentations, and at the bottom of this is extractivism as an unsustainable, outdated, destructive model of economic development, right? So this brings to the point of redistributing the benefits. How could we get there? What's the roadmap? So this is a map of biomes of the Amazon. It's outdated. It's from more than 20 years ago. From some of the, I like to highlight it to show the encroachment of agriculture. A lot has changed since. But based on this land use change over the last 20 years, and particularly in collaboration with Dulos Armenteros, who's right here and was presenting yesterday, I've actually come up with this generalized model of what is happening at that frontier. And that generalized model is, again, frontier. It's a forest frontier in which we begin with very small encroachment into the forest, and then we go into this rapid decline, right? And there's a transformation, and at the end, you get properties. And that's interesting because even though a lot of times we focus on deforestation as a physical process of transformation of forest and biodiversity, there's also a socio-economic process. And that social process is actually much more important and legal. Is that at the beginning we have the common pool resource, just like the biodiversity in nature, and then at the end we have some kind of private property. And that private property can be used as a credit to generate money. So this is a generalized model of what is happening in this forest frontier, the societal change. However, I would like to propose that unlike the destruction of the forest, the knowledge that can come from the genomes is renewable. And that is very important. The knowledge that can come through the genome doesn't have to follow the same extractivist model that we have had for the destruction of the forest. The genome frontier is an endlessly renewable resource that is part of a knowledge economy. So, but it's not going to be a knowledge economy that benefits conservation all of its own. This is not going to happen unless we make it happen. So it requires connecting these benefits of the genomes through some kind of traceability. So what does that mean? I want to bring up, so we may be familiar with this. This is a hockey player who said, you have to skate to where the puck is going, not where it has been. So we don't need to go back to something that's happening now. We need to see where things are going. And this is where things are going. So these are two examples from my own lab where we started working in what I call stakeholder-driven genomics. What that means is that we actually work with in-country partners that they tell us what they need from our genomics. Not just, I'm going to make the genomes and publish them, and something's going to come out of them, but actually, what do you want? And that is some of the conditions that you see. The big picture is actually happening in the slopes of the Amazonian side of the Andes of Colombia. So we are actually working with the Humboldt Institute, taking our sequencing in the field and asking, Humboldt, what do you need to know from our genomics, right? And they told us what to do, and we started working on the capacity building. So in Jamaica, which is where this picture comes from, one of the questions that people had is, what kind of animals are getting eaten by these feral cats, right? And are they endangered? And we were able to do that by bringing the lab to the field. So instead of, we're skating to where things are in the future, not where they are right now. So instead of taking the samples out and taking them back, we're actually going to the field and asking stakeholder, what do you want from us? How can we help you start your genomics so that you can take off and do it on your own? And answer your questions. This is a picture from the Andes on the Amazonian side with people from the Humboldt Institute. It was a really good expedition, and what came after got interrupted by the pandemic, but we're going to get back to it. I didn't even know. Okay, well, I'm actually done, I think. Yes, oh no, I'm not done. I'm great, I'm done. So to conclude, in terms of distributing the benefits, genomics has the potential to produce benefits for conservation. It really does, and it has more potential right now than it had in the past. Why? Again, remember, CRISPR-Cas, and the capacity for sequencing has just grown much more than we are able to actually analyze it. So the capacity, the ability for genomics to deliver much better than in the 90s and when with the InBio model is much greater right now. But these benefits are not going to come back to people on the ground unless we make that happen. This new technology enables what I call stakeholder-driven genomics, which I believe is the future of genomics if we want conservation to happen from genomics. Thank you.
Thank you so much, Liliana. We're going to save all the questions for the end. So if you think you have one and you're afraid you're going to forget it, jot it down somewhere and save it for the end. We're going to turn next to Dr. Adalberto Val. He's from the Brazilian National Institute for Research of the Amazon, INPA. Dr. Val, please, the floor is yours.
Thank you. Good afternoon, everyone. Thank you to the organizers for having me here this afternoon. And you have the bottom of this slide, my directions there. INPA stands for the Brazilian National Institute for Research in the Amazon. And PAC is Brazilian Academy of Science. That's partner of the SPA. And ADAPTA is a big program that we run in the Amazon. You have my direction there. And the first point, I showed this slide yesterday. When talking about the Amazon, we have to consider the size of the Amazon. The Amazon extends all over the countries in the north part of South America. And in the other one, in the blue one there, we have the Brazilian Amazon. The Brazilian Amazon represents around 60% of the Brazilian territory. And only the Brazilian Amazon is the size of the Europe. The whole biome is the size of the continental US. So it's a big area. When designing interventions in the Amazon, we should consider this size. And we have different characteristics in the different places in the Amazon. So it's 7.7 million square kilometers, the whole biome. Out of it, 5 million square kilometers are within the Brazilian territory. I should mention here that we have 40+ million people living in the biome of the Amazon biome. And only in the Brazilian part, it's around 25 million people. And here are some unparalleled characteristics of the Amazon. The first point there is the length of the Amazon River is 6,992 kilometers from the Nevado Mismi in Peru down to the Atlantic coast. And we have different types of water in the Amazon. And the picture there showed the meeting of waters that occurred just in front of Manaus, the Rio Negro and the Rio Solimões. From that point on, the river started to call Amazon again. enters Brazil as Amazon, then Solimões meets the Negro and back calls Amazon again. And the characteristics of the waters are completely different. I should say that 275,000 cubic meters of water enter the Atlantic Ocean every second. Every second. So it's an amount of water equivalent of 20% of all fresh water entering oceans worldwide. That represents an important resource in these days in the world. And also, another characteristic is that since the uplift of the Andes, the Amazons undergo lots of tectonic changes, disconnections of rivers in the Amazon. So disconnecting rivers means that we have a different evolution of the populations that are disconnected in that moment with different genetic characteristics. And then we have most of the climate changes that the region undergoes during this period preserved, let's say like that, in the genomic of these animals living in the Amazon. Here some fish species, some interesting ones. The first one there, the electric eel, can discharge some 600 volts in people touching it. So this is the reason that the local people use wood canoes, not aluminum canoes, you know. And then we have the piranhas, the small cardinal tetras, and the big pirarucu that grows up to 15 kilos in the first year of life. And then tons of different fruits and trees. And I select some example here. The first column, just aquatic plants. We have more than 1,000 different species of aquatic plants in the Amazon. 400 just around Manaus city, that is in the confluence of the Rio Negro and the Rio Amazonas. And then the second column, the middle one, is fruits. More than 200 different types of fruits we have just near Manaus. And fungus, tons of different fungus. We don't know even these species, all the species that we have there. We know some 0.1% of the species that occurs in the Amazon. And of course, insects. You know, that is the wood insect back there, just comparing to the size of the hand of people there. The biomass of insects in the Amazon is bigger than the biomass of mammals. So it's, and that we know just a few species that are in there. So it's lots of species to describe. And of course, science and technology innovation are needed to protect the Amazon rainforest. Some of the major challenges are shown here. Fire, deforestation in the Amazon, the cattle herd just in the legal Amazon 2020 is described there. Mato Grosso is a terrible situation like that. And mining, particularly illegal mining in the Amazon is a big problem. And in the bottom of the middle column there, you see how it increased in 2020. It's a big increase, a big degradation of the environment in those places there. And then, this is completely new data. The secondary vegetation, aged 6 years or less, in the Brazilian Amazon 2019 is represented in green there. That means that all those areas has been degraded for somehow during up to 2019. And of course, science and technology are also needed to review what is hidden in the forest. The the DOC, dissolved organic carbon, that gives the black color to the Rio Negro, somehow has some properties to protect the fish. We have more than 1,200 different fishes living in very acidic water, and this DOC protects the fish against acidity and pollution of the systems. And also some other drugs like the bergenin. The bergenin is a compound that's found in this plant here, the uxi, yellow uxi, and the pleural uxi. It's the price of 1 gram is higher than the gold 1 gram. So it's a very expensive drug that we have in the Amazon. And also this one here, just another example, elliptocin is a very potent drug against Plasmodium that causes malaria. And the biodiversity, it's a paper that I published 2020, represents also a very important hidden risks, particularly because of virus, bacteria, and fungus that we don't know exist in the forest. A pandemic would appear from that, you know? So we should be careful with this thing. Deforestation means stress to the organisms that is living in the forest, and we can have a zoonosis, virus jumping to man from the forest, you know, from these animals. And also, in addition to the tropical fruits, we have tons of different animals that are very important as food source in the Amazon. Protein from fish. Fish protein is the major source for the local people. Near 45 million people living in the region. The tambaqui here is represents in the back first column. It's a very, very common fish in the Amazon. This fish eats some 150 different types of fruits. It's a fruit eater. And the pirarucu is the other column there, is an animal that grows up to 15 kilos in the first year of life. I showed this yesterday. How this animal does that? This is we don't know is the answer. But how we can review this, all these things that are hidden in the forest, science and technology. Science, technology, and innovation in the Amazon are extremely low. So this is one point that we should consider when trying to design conservation in the Amazon. And the first column here is the evolution from 2010 to 2018 for several Amazonian countries. As you can see there, all the countries except Colombia and Ecuador had a very, all other countries had a very important decrease in the investments in science. Brazil is investing some 1% of the GDP, gross domestic product, in science. But the average, the world average is 2.63, as we can see the first graph there. But remember, in Brazil, over the last 4 years, we have a tremendous decrease in the investment in science. See the second figure there in the second column. So it's a tremendous decrease. That are the numbers, the figures for Brazil. But when we consider the Amazon per se, what we have is what's shown in this pizza graph here. So it's less than 2% that's invested in the Amazon from the total of the investments in science. What that results in what we call the Tordesilhas factor. Tordesilhas was the line designed to separate the worlds in two parts between Portugal and Spain. So that is the situation we have in Brazil. The red line is the Tordesilhas line that still separate what is the Amazon and the Atlantic part of the country, you know? So it's a terrible situation. In green here are the Brazilian National Institutes. There in red are the research groups that we have in the Amazon. So this is the government investment in science technology in the Amazon these days. We need some 1.6 billion to protect 1.3 million square kilometers in the Amazon. The annual cost for 3.5 million square kilometers is around 2.8 billion to be conserved. So if you compare that with the NASA budget, for example, that's around $25 billion per year. So it's less than 10% needed to protect the Amazon. So we need investments in several aspects of the Amazon, and the AMIT, that's the Amazonian Institute of Technology that we are proposing now, is thinking to invest near $1 billion in 5 years just to transform the information that we already have in new technologies to improve the social inclusion in the Amazon. So training is the way for conservation and social inclusion in the Amazon. Out of the near 4,000 postgrad programs that we have in Brazil, only 262 programs are in the Amazon. So we have to improve that training. 60% with 262 grad programs and near 4,000 in the other side. So, and Carlos knows very, very well this evolution of CAP's budget over time here. So it's a big decrease over the last years. It's completely different of the time we were there. So the basic situation here is what AMIT is proposing. We have to train people in advanced technologies for Amazon, human development for the Amazon, sustainability for the Amazon biome, environmental services of the Amazon, and apply biological science for the development of the Amazon. We think that we have to change a little bit of the focus for training in the Amazon in general. And bioeconomy is one way to do that. You know, social inclusion should be designed to connect people in forest for a better life. Just one example here is the Mamirawa Sustainable Development Reserve. There, they sustainably manage the pirarucu, and they collect the pirarucu, and the women take care of that. So it's a big program there that is kind of improving natural conservation, environmental conservation in that area in the Amazon. So summarizing these things, I have said the Amazon have unparalleled characteristics. Science, technology, and innovation are needed to protect the Amazon rainforest, but should be developed there. Science is a social action with social end. So we should involve the people of the Amazon. Otherwise, we develop the science, the information outside the country, publish the paper in all the best journals in the world in English, and the people in the interior part of the Amazon cannot read them and cannot benefit from the information. Science, technology, and innovation are need to review what's hidden in the forest. Government investments in science, technology, and innovation in the Amazon are extremely low. We should, improve these investments in the Amazon. Training. is the solution, is the way for conservation and social inclusion in the Amazon. And social inclusion should be designed to collect the people and the forest for a better life. Thank you, Isabella.
Thank you so much, Dr. Val. So I hope everybody's starting to get a picture of what we're talking about. Dr. Val very clearly showed sort of the scale of the opportunity of the Amazon, which is so vast, almost so that it's hard to wrap your mind around it. The number of species, the volume of water, and with the points that Dr. Dávalos made as well, with advances in genetics, we really have an unprecedented opportunity for a sustainable knowledge economy that, if done correctly, can really return benefits to the communities that we're talking about. We're going to turn to another speaker, our next speaker, who's trying to put this practically into practice on the ground. We're going to hear from Maria Luiza da Oliveira Pinto e Paiva, who is the Executive Vice President of Sustainability for Vale, and has a long career of working for sustainability and inclusion at a number of companies. The floor is yours, please.
Thank you very much. Well, good afternoon to all of you. First of all, it's a pleasure, it's an honor, and it's quite a challenge to be here. Why? A lot of scientists in this panel. I'm not a scientist, Emma, right? So a personal challenge, how to honor all your knowledge or your investment. Also take the opportunity to thank you, Emma and Dr. Carlos, for SPA, all the work you have been doing. I mean, you have been helping the Amazon region on a very unique way, being able to put the best minds of 9 different countries, to work on the solution for what makes me to feel a little bit more comfortable of being here, because the cause is the same. I'm not a scientist, I am executive, but I think we have the same cause. Fight for the preservation of our dearest biome. So, Vale is a leading mining company, iron ore, nickel, we produce. And we are present in the Amazon biome for more than 3 decades now, more than 35 years. And our commitment with the region is an environmental commitment and also a social one, okay? And what I think makes us to be part of this group here today is that the way that we are working in this biome is a lot through research, is a lot through science, right? Just to give you an idea, coming back, tem que apontar lá, tá certo, it's here. On your left, what you see is a GIF that shows what has been happening in the region where Vale is present in the last 3 decades. Unfortunately, this only green piece that's left is the native forest that is our obligation, that's Vale's obligation to preserve. Unfortunately, when you see it around, our 800,000 hectares of preservation, it's gone. You know quite well, Adalberto as well, I think everybody knows quite well the situation. We mine within this mosaic. It's a mosaic formed out of national parks, conservation units, and we also have our neighbors on the left side, the Xikrin, the indigenous people, the Xikrin people that are very close to us. And together with the Xikrins, with the help of the Biodiversity Agency, the Brazilian Biodiversity Agency, we preserve these 800,000 hectares. We mine. We use only 3% of the 800,000 hectares to mine. All the other parts are really for preservation. And I think that what's important to say also is that, for me, this is our business case. I think what we can show here is that it's possible to have a business, a competitive business, happening in the Amazon biome, preserving the forest, making sure that you have fauna, flora, and people living within the forest. And how we do that? Through different initiatives, let's say, just to give you some examples. We are working, as I already said, with science and technology. We have a lot of investments being made in innovation and entrepreneurship. We don't do anything by ourselves. That's one of our rules. Everything is done on a partnership, local, national, international partnerships, specialists from different sectors also. So what we have been doing today, you can see, I cannot read, okay, from a long distance. That's why I have the page with the papers with me, okay, guys? So you can see what we are focusing on the left, right? So market development, supporting service, capital offering. And how do we do that? For instance, we have launched a few years ago the AMAS accelerator. It aims to work with startups, okay, that are creating or generating revenues or for families, okay, that preserves the standing forest. So how standing forest can generate income for the local families. That's the AMAS one. You can have also the Previsia. Previsia is based on artificial intelligence, how it helps together with Microsoft and other partners. It's helping us to identify risk areas, risks in terms of deforestation and fire as well. So the Previsia is helping us also on the prevention side. The Jornada Amazônia, it's another example of also another partnership for science. So to be in the Amazon for us is not about mining, it's about mining, responsible mining, and fostering science to make sure that we face our challenges. Just give you some concrete examples that are very much, some of them relate to your presentation, Liliana, and Adalberto as well. Adalberto, I think, knows quite well our operation down there. But just to give you an example about genomics, okay? I think Vale has a unique asset. We have a very top lab in the Amazon region, based in the Amazon region. We call it ITV, Instituto Tecnológico Vale. And we are working with genomics, fauna and flora genomics. On the left, you see a picture of the arpaia, I don't know in English, arpaia, eagle, right? So we have now the whole DNA of this arpaia eagle. And on the right side, we also have the same being done for the, let's say, for a type of flora on the altitudes of the biome of the Amazon region. So working with science on both sides. And what it has to do with us, we believe that if we have to learn more to be able to preserve better, to invest better, but not only on those type of things, but we are also working with genomics to make sure that we are able to help the Amazon population to have better income. So here you have two different examples. We are working in the Jaborandi that produces the pilocarpina. Pilocarpina, it's important for a medicine for glaucoma, okay? So in this case, on one side, I have our research, our ITV Institute work on the genomics of the pilocarpina. In the other side, I have the social team working with the association, okay, that collects the Jaborandi that produces the pilocarpina. So social and environmental economically, we have to be present on both sides. The second one is cocoa. Cocoa is one of the best chances for our local, for the native people, to really have income generation programs. So we are working to find better and better cocoa seeds so that they can have a better production, so to sell more, so to leverage the quality of their lives. So again, we want to work on both sides, on the science side, on the genomic side, and on the social side. They have to be combined. So, because we do believe that are both together that will preserve the standing forest, right? Another, here it's more general examples of other things that we are doing in the region. But I think that the most important one is that we have been there for, as I said already, for more than 35 years. Some learning from all these phases. The biggest challenge nowadays is about to scale up. Anything is about to scale up, being on the flora or on the fauna side, being on the social side, mainly the social side. We are using ITV as our science, let's say, team as a basis to help us to develop models for small communities to find a way through the bioeconomy to leverage their income, but more than income, education and health as well. Last year, we announced a long-term goal. We want to be part of a movement to lift up 500,000 people out of extreme poverty, right? And bioeconomy is going to be one of the main tools, let's say, to make these people to really, but before, we have also to invest on social, being health, being education, and infrastructure. We have another goal, that's to restore 500,000 people, 500,000 hectares of native forest, okay? Out of the 500, 100,000 we want really to restore, and we want to preserve the other 400. So everything we are doing about genomics is also to help us to understand what type of trees and seeds will better solve or help us to find the solutions. We also have to look for different type of fundings, you know, to go out with good projects, and then that's also important to be here with the SPA. And we have a lot of work being done also with our indigenous people, our neighbors, helping them to empower, to being able to really design the plans of their lives, and we will support them toward those plans. Time is over. Thank you.
Thank you so much, Ms. Paiva. And I think we can all agree that the kinds of transformations we're calling for in the Amazon will not get anywhere unless we're working with exciting private sector firms like yours who are really trying to advance as far as you can on issues around sustainable development. Our next speaker is Dr. Carlos Nobre. He's a Brazilian Earth System scientist, and he is a member of the Brazilian Academy of Sciences, the World Academy of Sciences, the U.S. National Academy of Sciences, and very recently, the Royal Society. Dr. Nobre, the floor is yours.
Thank you, Lauren. Good afternoon to all. Thank you very much. Let me say, I will talk a little bit about on this big challenge, how to transform the Amazon into the bioeconomy superpower. If you were here yesterday, my colleague Marina Irota, she's here. She presented the risks the Amazon is going through. We call savanization, to lose 50 to 70% of the forest. Talk a little bit why we need to save the Amazon of this risk, transforming, creating this new bioeconomy. I call it the Amazon Green Deal. As you know, to combat the climate emergency, globally speaking, we have to transform greenwashing in Green Deal. US is the Green New Deal, Europe is the European Green Deal, but we need an Amazon Green Deal. So you've seen this yesterday. This is the more than 2.2 million square kilometers of the Amazon forest has been degraded. It's about the same amount deforested and degraded. Also, wildfires are becoming a serious risk. The forest evolved over millions of years without fire. Now the fire is spreading. More than 150,000 square kilometers of forest has been damaged by wildfires. Very, very serious issue, and myself, I'm a climate scientist. This is really the data that worries me a lot, which is the southern Amazon, 2.5 million square kilometers. The dry season is 4 to 5 weeks longer in 40 years. So if the dry season exceeds 5-6 months in this area, they will turn into this degraded savanna. So basically, we are very close to this tipping point that we say deforestation exceeds 20-25%. It's now close to 18%. The global warming also is inducing more frequent extreme droughts in the Amazon, and then degradation and wildfires. So we are at the edge of this tipping point, so we really have to act very quickly. The tipping point is mostly in the southern Amazon. I told the dry season is longer, hotter, even drier. The Amazon since 2016 has become a carbon source. The southern portion of the Amazon is a carbon source even during the wet season. The whole Amazon is a carbon source because of deforestation, wildfires, and degradation. And so what does it imply? As I said, we are very close to the tipping point. There is a risk of losing 19 to 26% of these tree species, risk of losing 60-70% of the forest in 50 years. That would emit 300 billion tons of carbon dioxide. Remember, to keep the Paris Agreement targets, the maximum emission of CO2 is 400 billion tons globally. Fossil fuel, all. The Amazon will make it impossible. So also will affect, of course, the food production, the exports, the economy, and tremendous risk of social environment. Let me move here. So as you've seen yesterday, and you've seen today as well, the Amazon has the highest biodiversity on the planet, 13% of all known species of plants and animals. But biodiversity really still not well known. The red is only the species which are known. The potential, we have to learn much more about biodiversity. Liliana was talking about also the genetic, the potential of genome, the genetic potential in the Amazon. So basically, so the panel made some very serious recommendations what to do to reduce the risk of the social and ecological tipping points, stop deforestation, degradation, wildfires. The governments have to have a new policies, new governance for the Amazon. And then let me start just saying what the panel recommended, a big forest conservation restoration project. Basically, linking the bioeconomy to restoration, stopping pollution, stopping the disconnection of aquatic ecosystems as well, and of course, stopping deforestation degradation. So it's very important to create perhaps the largest global project for forest restoration. And at COP26, the panel is producing a policy brief to be released during COP26, which is really what we are calling transforming the arc of deforestation in arcs of restoration. These two arcs, the largest one in southern Amazon, and of course the arc around the Andes. Those are the areas with this 2.2 million square kilometers of deforestation and degradation. So that's the idea. Let's restore more than 1 million square kilometers. This is very important also to preserve biodiversity, to provide the means for this new bioeconomy, to protect the indigenous people and the local communities. Let me say just one thing here. I forgot to say. This secondary forest is also very important agroecological systems. And 1 hectare of a secondary forest growing for 30-35 years removes between 11 and 18 tons of CO2. So this project would remove for 3 decades more than 1.5 billion tons of carbon dioxide a year. So this is essential also to combat the climate emergency and to protect the Amazon. So, and also, of course, Adalberto already mentioned why we need a new bioeconomy we call a healthy standing forests and flowing rivers. So this is, let's say, also to bring industrialization, to add value to the forest products, benefiting rural and urban populations. So basically, it's this complex, not easy, but this is our challenge, how to connect social biodiversity with all the Amazonian people, how to link high tech with indigenous people and local communities' knowledge. So this is the challenge that we all face. As I mentioned, agroecological systems to restore forests, they're very important. You know, after several decades, they may have 60% of biodiversity. They may recover 75% of carbon. So agroecological systems have a tremendous potential. Here, just one data, sorry, it's in Portuguese, some of this, just to compare acai berry. As you know, all of us know acai berry. 20 years ago, acai berry was an Amazonian product. Nobody outside of the Amazon knew. Now it brings $1.2 billion to the Amazon economy. So basically, look at this, just a comparison between, and this is a comparison, now these agroecological systems with acai berry, with, you know, Vale also is supporting cocoa, agroecological systems, they are benefiting more than 500,000 families. More than 500,000 families. They were extremely poor family farmers, small-scale landholders, and they moved to agroecological systems. They moved from extreme poverty. Now they are poor, and some of these people are reaching the middle class. So this is just to indicate the potential. And here, this is the data on many studies. This is not a projection. This is just a comparison. 1 hectare gives a profit of $100 of pasture for livestock farming, cattle, and the 95% of the first deforestation is for cattle ranches. This is soy. Soy is increasing the price. This is 2019 figure. Now soy is $600 per hectare, which is a big threat also as well. But look at the acai berry. Average profit from acai berry, 1,000. So improve the livelihoods of all these communities. This is without industrialization. This is just exploring these products. So basically, this new bioeconomy is just to really bring this entrepreneurship, eco-predators, all those things. Also, the ecotourism has a tremendous potential, not much used in the Amazon. Liliana was talking about the tremendous potential, genetic potential. And also, Adalberto mentioned one of the initiatives of the Amazonian Institute of Technology, we call in Portuguese AMITI, is also to bring the knowledge, the genomics knowledge, to the Amazonian people, to the Amazonian communities. This is not only something to be high-tech only in developed countries. This is to bring the potential of genomics. And of course, the food chains. Sorry, I mentioned all these things. And this is the great potential. I just want to say, we made a survey there, just a simple analysis, how many biofabrics we have in the Amazon, in the communities, and biofabrics associated with products from the Amazonian biodiversity. It's really a negligible number. The craftsmanship of indigenous communities, this is the largest number. Pirarucu fish, oil, pulps, and butter, energetic juices, pepper, seedlings, and chocolate. Only perhaps chocolate has a more high tech. All the others are very low tech. This is less than 50 biofabrics in 6.5 million square kilometers. 2 streets here in New York have more companies than 6.5 million square kilometers. So that's really the challenge. We have to really bring industrialization. So this is the idea, this bioeconomy of social biodiversity. It's a big challenge. There is no fully developed tropical country in the planet except Singapore, but Singapore has nothing to do with the remaining forests they have there. Singapore is today financial world, digitalization, in the past naval industry, oil industry, but no other developed country in the tropics. So we have really to develop this bioeconomy of social biodiversity. So this is the alternative to avoid the destruction of the Amazon. So we need to have these inclusive models, how to develop. Science technology, the Amazon Institute of Technology is our initiative for that. How to merge with indigenous and local knowledge, how to develop global markets, local and global markets, and to produce this equitable development. So basically, this is the frontiers for this bioeconomy of standing forests and flowing rivers. We really have also 65% of Amazonian population is urban. We have to see how to improve connectivity between urban, also rural and peri-urban communities, high quality connections also, and changing the design and implementation of sustainable infrastructure. 95% of deforestation is within 5.5 kilometers of roads. So we have to find a green infrastructure system for the Amazon, very innovative. And of course, we need institutional financial support. We have to convey the message to the global investment world to invest in this new bioeconomy. And of course, recognize the importance of knowledge accumulated by indigenous people for thousands of years. So basically what we want, the Amazon Green Deal, to save the planet from climate emergency, to protect biodiversity. See, this is nature-based solutions, how to create this, to transform Amazonian countries in the top environmental powers of social biodiversity, creating this novel circular bioeconomy, the superpower bioeconomy, and of course that has to bring jobs, well-being, prosperity. It will protect biodiversity and also combat climate change. So these are the 4 key messages of the Science Panel for the Amazon released during COP26 in Glasgow. Urgent messages: moratorium on deforestation, degradation of wildfires in southern Amazon, immediate, zero deforestation, degradation in the whole Amazon by 2030. Almost all Amazonian countries signed the agreement in Glasgow about that. But unfortunately, they signed the agreement, but that's not the trend. 2022, we are seeing increase in deforestation, explosion of forest degradation and wildfires. We have a record-breaking wildfires in the Amazon, in Brazilian Amazon, in the last weeks, over 15 years. And of course, this big arcs of restoration, forest conservation and restoration, and implementation of this new standing forests and flowing rivers bioeconomy. So this is the unprecedented challenge, how to develop. There is no example. So most of the developing countries, how they look for development. They look how developed countries did, solve the problem for centuries. Now, we don't have that model in the developed countries. This is a new model, so we have to create. This is an unprecedented challenge, but we have to face that. Let's save the Amazon, let's save the Amazonian population, the Amazon we want. This is the message of the panel. Thank you very much.
Thank you so much, Dr. Nobre. I think your call for urgent action could not be more clear, and I appreciate, too, that you're bringing it with a solution. Love the idea of the arc of reforestation, building resilience to the Amazon against climate change, fighting climate change by mitigating emissions, generating great local livelihoods in agroforestry systems. Fabulous. Our final speaker, last but not least, is Ms. Belén Páez. She's an Ecuadorian ecologist, and she's the director of the Pachamama Foundation. The floor is yours. Oh, I'm sorry. We're going to pause just for 1 second to get updated slides. Please bear with us. but it will still be the advancer, and they will be up in a moment. I'll remind everyone to start thinking of your questions, because we'll have some time for discussion after our final speaker. The protocol for that will be to raise your hand. We ask that you wait, because we're going to bring a microphone around to you so that you can talk in the microphone and our online audience can hear you as well. And if you are with us tuning in online, you can use the chat feature in YouTube to ask questions, and we will be reading them out here in the room. I think we're still waiting for the slides to come up. I'm sorry, Belén. Okay, I think we're ready. Maybe not. Great. Thank you, everyone, for your patience.
Hello, everyone. Very nice to see you all here. So many friends here in this room. Thank you to Emma and Professor Nobre and Isabella to make this effort to do these conversations over this week, and also before the Climate Week next week, an important week for the people who's going to participate in these conversations. As Carlos said, we don't have enough now more time in order to act. There is a lot of challenging times in front of us. Things are happening now. And in order to walk to the transitional pathways and to start doing these radical changes that we need to implement, we really need to, in one hand, to stop the economic model that is a death economic model that is destroying the Amazon region, that is destroying the biodiversity, and going into this transitional pathway that will support us to start in this new economic model that includes the standing forest, the living forest alive. And to me, this is a really important principle of the work that we are doing in the Amazon of Ecuador and Peru. So all the recommendations that has been said and mentioned in this panel, we are in the ground implementing right away, and we are doing this in the last 25 years. But this is not possible if we have not been partnering with indigenous peoples all over the Amazon region in Ecuador and Peru, from the Andes in the Amazon, from the Andes Amazonic in the Amazon region in Ecuador and Peru. And my personal experience has been that because of the strength of the indigenous organizations in Ecuador and Peru, especially in Ecuador, I'll tell you an example. For example, 2 months ago, the indigenous movement went out to the streets in Quito, and they were asking very specific questions to the government to end poverty, to be more inclusive, to have more participation into the development of policies. And what happened right now is that after 90 days of conversations in between the indigenous movement from the Amazon, the Andes, with the government of Ecuador, there are some important news, like the government has been stopping some of the oil and mining concessions in the Amazon region. They have put out a moratorium. They have been putting out task force of transitional pathways to start thinking carefully what is the possible future for the Amazon in the next 10 years, in the next 20 years. So this is a really a good example of what can the indigenous movement can be doing in Ecuador and Peru. So in order to start telling you more about the superpower of the bioeconomy in the Amazon rainforest, I really do believe in my heart that this is a superpower. And we have been witnessing this with indigenous peoples over the last years. You already have listened to the scientific panel experts on what are the really bad news about what's happening, and we are reaching the tipping point. So I'm not going to stay here, But what I would like to say is that bioeconomy has opened a new world of opportunities to build an alternative paradigm that generates livelihoods without devastating biodiversity. So we have been working with over 25 indigenous nations, more than 15,000 people around in the last 2 years, several good experiences of sustainability to restoring forest. Community involvement, indigenous involvement, very important to the work we do, and the inclusion of traditional practices together with the development of knowledge-based and new technologies have allowed the creation of successful value changes. So the Amazon is one of the most biodiverse places on Earth, especially in Ecuador and Peru. There's some of the hotspots around the Amazon, so it's a really a place with a lot of biodiversity. And there are, of course, new technologies and knowledge that also are like traditional knowledge that have been very developed the latest years to create this new path of the bioeconomy path. Possibilities to be more efficient and sustainable, yes, that is happening now, and growth of bioproduct markets. So an example in what is happening in the Ecuadorian Amazon, the 99% of the forested area in Ecuador is transformed into agricultural areas. For this reason, there is a national effort to support a transition into sustainable zero deforestation with agricultural production systems. So this is like an effort that the government of Ecuador is putting ahead. In 2020, 34 public and private institutions in Ecuador joined the National Pact for Sustainable Bioeconomy. So this is the Green Deal that is already happening in Ecuador and in Peru as one of the country's milestones to develop of the bioeconomy. Pro-Amazonia is also a program from the government that supports approximately 8,000 beneficiaries, most of them contemplating indigenous peoples. So the program we ran inside of Fundación Pachamama with 23 indigenous nations are called the Forest Economies Program. And this is because I've been listening to Carlos Nobre for many years about telling us how important it is to call these projects Forest Economies Program, the Living Forest Program. So Fundación Pachamama is working together with local communities. Some of them maybe you have not heard about, but I would like to mention them, the Achuar, the Zapara, the Shuar, the Quichua, the Waorani people, in more than 3 million hectares in projects related to bioeconomy. So some of the objectives are develop innovative Amazonian value chain, promote the conservation and restoration of the forest, promote well-being, food security, and maintenance of community livelihoods, generating capacities in the communities, and work through local and regional alliances. So now we are not by ourselves working like alone, but we have been able to put in place an ecosystem of collaboration with the government of Ecuador, with the local subnational governments, with the universities, with indigenous peoples, with private sector, who's really coming organically, very active to participate in this kind of new possibilities, and it's happening. This is the map of Ecuador, some of the places that we are expanding with some of the value change that I'll tell you more about. So one of these beautiful plants that we are working with is the vanilla, that is an orchid that grows wild on the banks of the Amazonian rivers and within the forest. It is the second most expensive spice in the world after saffron, and thrives in the tropical climates. There are many new species that have been founded in the Amazon of Ecuador of vanilla. So people is really engaging to start doing this work, and also because they don't need to have the forest in order to plant the vanilla. This is an orchid that can grows into the gardens, and you don't need to deforestate like a huge plot, because vanilla is very generous. You can work in a small place and you can grow and have really good benefits from this. So the revenue from its sales in Ecuador reached 40 million in the last years, 20 times more than 5 years earlier. The price per kilogram of Ecuadorian vanilla correctly fermented exceeds $500. This is one of example of some of the examples that the value chain we are working with now, and with vanilla, with Amazon cinnamon. Some of the laboratories that are in the ground with the actual women, they are working now with essential oils. They are like expanding and training other women from other communities. And they are really also with these projects being able to participate more in their organizations and have more chance to have incomes to support livelihoods in their communities for especially education and health. Morete, Maurita flexuosa, and Guayusa, some of our beautiful, beautiful projects, superfoods, that now have been expanded into the global markets through tea. The Guayusa tea is one of these energy teas that comes from the Amazon in Ecuador. As well, Morete has been turned into a energy beverage that has been expanded now into the whole region of the Americas. And ecotourism so far in the last 20.5 years has been really impactful in the economy of communities in the Ecuadorian of Amazon. There are several experiences. One of these that I would like to share with you is the Capawi Lodge, has been award and winning indigenous communities. And the Amazon, the territory of the Achuar people that has been threatened over the year by oil companies, they were able to stop oil development in their territory because they showed to the government that they have incomes that are exceed to whatever was the government budget that they have to put in place projects with them. So with these ecotourism activities, they were able to stop economies that were not for life, but economies that were for having a live forest in place. There is also a new kind of tourism that is like, it's very revolutionary because over the last 5 years, like I will tell you, around Peru and Ecuador, more than 100,000 people has been visiting communities in the Amazon to receive treatments from the indigenous communities. As someone mentioned earlier, as in the Medicine Man, the movie. So people has been treated by trauma about any diseases in the whole body, mental diseases. So this is also an opportunity that brings incomes to the communities all over around the Amazon in Peru and Ecuador. And nowadays, like people are expanding these kind of projects to treat with traditional knowledgement, especially dreams interpretation, using medicinal plants. And I'm not just talking about ayahuasca experiences, but I'm talking about all different kinds of treatments to heal trauma and support people to become more aware about the Amazon. So the people who's visiting these projects, after visiting, they are aware about what's happening in the Amazon, and they put money to start projects in the community. So it's a really reciprocity coming from these bioeconomy activities. Just to end, I would like to mention that any kind of biodiversity or bioprospection project or ecotourism project that will be implemented in this region must to have the involvement of the stakeholders. We need to fulfill the safeguards that the RED Plus project has been developed for the last 10 years. And this is such an important and critical thing, as the Cancun Safeguards says. Any project that will be related with RED Plus or voluntary carbon markets or biodiversity must have the full participation of indigenous peoples. They need to participate, but also they need to be the really beneficiaries from the funding that is coming from outside for forest and also for biodiversity, and acknowledge their knowledge, traditional knowledge, and knowledge that they are the guardians of the forest. So this is some of the experience from the heart of everywhere that is the Amazon in the Ecuador and Peruvian side. Thank you.
Thank you so much for sharing all that incredible work that is currently happening right now in the Amazon and could be scaled up everywhere. We have time for questions. So again, if you would like to ask a question, raise your hand. Please wait for the mic to come around. We'll start over here. I saw 3 hands. This one, pink and then red.
Thank you so very much for all the attention and the voices and this dedication to the climate and to the planet. I'm Fiona Bannister, and I have a group called decarbonized.org. And Decarbonized has now got a team that's one of the most leading teams of scientists and Indigenous women scientists for the Carbon X Prize team of the X Prize side of the rainforest. And when we talk about biodiversity and conservation, that's where we've got some of the top experts here in this panel. Where do you feel that technology can interface as well as provide the access to data conservation? Specifically, what I'm looking at is for the Indigenous people, the DNA of their plants, of their medicines, and how do they get paid to be part of this global economy that's trading their carbon? And where do we stop the carbon market trade for now until we get a model that can be measured and measurable so that they can be paid to be the stewards of the forest? Thank you.
I'm going to suggest maybe Liliana and then Belén, maybe want to come in on this one?
I think that's a really amazing question, because it's like combining 2 different dimensions, like what is the biology. One of the key issues actually in tropical forests is that the measurement, the actual carbon measurements associated with the diversity of species and within species variation that exists from tree to tree or from stage of growth to stage of growth, it's poorer naturally for a tropical forest than it is for temperate forests. And only for temperate forests, some of that variation that I just mentioned is only being measured right now. So the question that you ask is essentially part of what the X Prize is about, right? Like, what is that individual variation that could enable us to have a return? One of the interesting things about the Nagoya legislation, so I'm just going to put that as an example, because in Nagoya the Nagoya legislation is not associated with carbon. It's about DNA. It's about genetic resources. Is that each country has a choice to implement it in a particular way. And although access to genetic resources and benefit sharing is about local communities, it doesn't always translate. Sometimes it just goes into a particular government agency rather than being able to make those payments. So I think that one of the ways in which we can advocate is that internally within the countries is that the regulation and the interpretation of instruments like the Nagoya Protocol have an actual component that is community-based as opposed to government agency-based exclusively. And that would be one practical way in which we can start putting together an infrastructure that is responsive to the moment when our technological capacity in the tropics is able to assign that value.
Just to add, I really believe that the indigenous communities had the chance to do with technology, to be able to do the monitoring and of any kind of projects, biodiversity projects, carbon projects. That's so important to training local people to start putting in place all the knowledge that they have in terms of going around the territories and monitoring everything what's happening, because they are also the guardians of the forest. They are like defending their rights, and in terms of norms and policies, indigenous people, in the case of Ecuador and Peru, they can participate in a better way to planning and develop the carbon voluntary markets, I'll say, in their territories, not just being under jurisdictional projects, but participating in a way that they can be able to have nested out or carbon out projects and have full participation and being able to receive the funds and to have negotiations that will allow them for the next 30 years to have the best prices over their plans, because they do have life plans. They do have a vision of what they want to do and accomplish in the next 10, 20 years. But it's also true that these populations are growing very fast in the Amazon. So we need really to make sure that participation will be one of the key aspects on these kind of projects.
Hi, everyone. I'm Paulette Hale, and I'm CEO of Cygnus Energy and founder of Cygnus Renewable Energy, which is focused really on developing renewable energy projects really globally. And so thank you so much for the information you shared about the potential of the biodiversity economy in the Amazon. And my question is, what kind of mechanism do you foresee that would support the indigenous entrepreneurs in terms of bringing financing directly to finance some of the amazing opportunities that you've outlined, to bring it straight to the entrepreneurs? When I look at something like the opportunity for the acai, and I see acai everywhere in Whole Foods, and how do you really make this like really thriving economies that that can preserve the Amazon, the biodiversity, and bring an economic appreciation and value to the people who live there? Thank you.
I'm sorry. Anyone want to jump in on that one? Carlos, please.
Well, to start talking, we call this new bioeconomy is flowing rivers as well, because as you know, your organization, the potential of renewable energies is all over the planet. It's gigantic. In the Amazon, yes, solar. In part of the Amazon, also wind is also, there's a potential for wind. And also, I forgot the name in English, but this is the hydrokinetic energy, the river, I forgot the name. Green hydrogen, all those things. So, yes, this new bioeconomy for the Amazon has to be using renewable energy. The potential is there. But, what Professor Adalberto Val, myself, and others, we are trying to develop in the Science Panel for the Amazon as well is the so-called innovation hubs. They will be, and we are certainly have to find this challenge of getting the funding for creating these innovation hubs. Some people call a biodiversity Silicon Valley. So this is a big challenge. So we really have to motivate the financial world, government financing, private sector financing, the innovation hubs. So this idea of the Amazonian Institute of Technology is one element, not the only one, but one element, how to create this technological innovation centers to provide the education that the local communities, this is the Amazon Institute of Technology in the Amazon, to educate thousands and thousands of people, including indigenous people. So the creation of the Amazon Institute of Technology from day zero will bring the indigenous people. We want really to have a good partnership with your initiatives. Yeah, and so that's the idea. And also, we call, Nagoya Protocol always say access and sharing of knowledge on genetic resource. But now we have to challenge the Nagoya Protocol and say, let's do capacity development for the Amazonian communities, including indigenous communities, for them to be able to access the knowledge. They have the traditional knowledge of thousands of years, but why not them being able to also use innovative technologies? And then to do, as you mentioned, acai berry is a good example. Yes, why not having thousands of companies, including companies of the indigenous people, of local communities, urban and rural, in doing this value adding. So that's the challenge of this new bioeconomy, and in particular the Science Panel for the Amazon. If you read some of those chapters there, they are moving in the direction of really how to find solutions for that.
Just to add, in agreement with everything that Professor said, to reach the money, to find the money is one challenge, but I think the biggest one is to really make people able, you know, to be educated. So regarding the indigenous people, we have been investing a lot in their infrastructure and things like that. But now, like 2 years ago, we decided to invest in the education at higher level because they have been able to enter, to access the university, but they are not able to stay. They don't have the money, they don't have the means to stay outside their homes, you know, for a month. They don't have a laptop, they don't have anything. So it was a kind of, they now are reaching the university. They are reaching, but they are not being able to stay there. So how we have to look at the whole cycle, you know, at the whole cycle from the financial perspective, from the education perspective, infrastructure, how do they get there? We are talking, when I was mentioning the scale challenge, okay, how we have now good models for the SAF, for the agroforestal model. I think we found very good models, being cocoa or any other type of crop. We don't have the people to operate. We need new businesses. We have the money to invest in new small businesses. We don't have them, the people ready. You know, so I think capability, the training and the capability, being indigenous or no indigenous group, it's one of the key challenges that we have there to be able to scale any type of good idea or any type of good model.
If no one else wants to, oh, okay. You're next after.
We have a question from the YouTube live stream from Vera Val, who's an author on the report. And she asks what the effects we are seeing of climate change on the Amazon biota and what are the consequences for biodiversity and bioeconomy.
Dr. Val.
That's a $1 million question. One point that we have learned over the last few years is that most of the aquatic organisms of the Amazon are living very, very close to their critical temperature. So if we have a very small increase in the environmental temperature, we can have a displacement of these organisms. They will try to find cooler places around their environment, around their habitat. But the problem is the Amazon River runs very close to the equator. There is no connection to the north, so they can migrate to the north. That would be a little bit cold, and very restricted ways to reach the south. So there will be a big selection of the organisms that can live in higher temperature there in the Amazon. It is a wrong way to think that because they live in higher temperature in the Amazon, they would support higher temperature. They are living very close to their limits. So in terms of food security, for example, we have to develop the ways using genetics, for example, or using selection techniques based on the morphology of the animals, on their physiology, to select the animals to raise them in farms to support the demand for this kind of food in the Amazon. That's a big opportunity for the system too, you know? And so that would be the same for several other organisms in the Amazon, like some types of plants too, some fungus, some insects, and so on. Everything is connected. If we have the disappearance of one specific species of insects, for example, we have a tremendous impact on the system because of the pollination, for example. So that's a big problem. In terms of fungus, for example, in our laboratory, we have showed that they grow a lot better in higher temperature. That's okay if we can eat them, you know, in our soup. But if they represent a medical problem, that would be worst for us, So the impact of climate changes on the Amazon, on the organisms of the Amazon, cannot be generalized, first of all, and second, represents a tremendous opportunity for developing alternatives for food security.
Let me just complement one to Professor Val. The science panel made that review as well. If you look from Bolivia all the way to the Atlantic Ocean, mostly in southern Amazon, there is a very large increase in tree mortality. And those are wet climate tree species. The Amazon has also tree species that exist in the tropical savanna to the north and south of the Amazon and in the Amazon. But those tree species are not increasing mortality. But the wet climate tree species, which in the Amazon are something like more than 15,000 tree species. So very high tree mortality. So this is the combination, synergistic combination of local land use change, deforestation, degradation, wildfire. It's making, Marina yesterday showed the data, it's making the forest much less efficient in recycling water, with global climate change, which is inducing more severe droughts in the Amazon, 2005, 2010, 2015, 16, 2020. So we are already seeing, so the risks are there. This is not something in the future. This tree mortality is increasing tremendously in these 2.5 million square kilometers. So that's why we say we are at the edge of this tipping point. And because, if there is this degradation and there is this savannization, hundreds of thousands of species will be extinct. So this is a very serious issue.
And let me add one point, just a minute. Another point that we have to think about is we have waters in the Amazon that are very hypoxic, low in oxygen. They have very low oxygen. They are warm. And in some places we have acidic water, like the Rio Negro, pH very acidic, less than 5. In some marginal lakes of the Rio Negro, the pH is as low as 3, and we still have fish there. If you have an increase in carbon dioxide in the atmosphere, the system will be even more acid. The increase in environmental temperature would make the water even warmer. And the increase in CO2 decreases the oxygen in water because of the partial pressure of the two gases. So these combined effects pose to the animals more challenges. And if we have some other anthropic disturbances in the system, like pollution, for example, that would be even worse in the system. Like, for example, crude oil. Crude oil mining is a big problem in the Amazon. That's because the temperature effect, because many fish species are air breathers. They must come out of water to breathe. What they find in case of an oil spill is exactly the oil on the top of the water column, and that is a big challenge for them. And temperature affects this relationship. So that's a big connected system that poses new challenges for these animals.
Hi, thank you guys so much for being here and sharing your information. I'm Megan from Amal Alliance, which works to empower displaced children through social emotional learning and peace building and so forth. My question is, how do we address the challenges that come with industrialization and the possibility of economic growth, such as disrupting the indigenous cultures and their ability to access that growth themselves? Or in other words, like, how do we protect indigenous populations from being taken advantage of by outside players coming in to reap the benefits of the Amazon?
Do we maybe want to do the opposite and do Belén and then Liliana this time?
I think that's a very important question, and also is now a really philosophical question, because we don't have more time in order to keep continuing analyzing, I'll say, like concepts about what is possible or not, but we need to act, and we definitely need to change radically the way that economics are like destroying the Amazon. And that's why we call the economic, the transitional pathways to a new economy must have a different perspective of what's our economy based on. And so there are like many possible solutions, but we need to have a plan over the time. Like over the next 10 years is really crucial to start engaging all the levels of the ecosystem, like I'm telling you about the government, local governments, indigenous peoples, academic sector, youth movements in general. And I think there are good examples happening everywhere in different places in the world, especially in the Amazon, to turn into this new pathway. And I think it's very important to definitely start having deep conversations on that the economic-based model, like oil and mining, agroforestry that has not been controlled, all these kind of economies are not going to be, they are not bringing any solution into the next, like close future, into the region and into our lives. So I would love to see that in the next 5 years, the engaging of youth and indigenous peoples into these transitional pathways are going to be seen as one of the biggest and greatest solutions for our next generations. So I think it's crucial now to start like giving answers to the governments to fight poverty, to work with the external debt conversations, to end down especially structural conversations, macroeconomic conversations. And I think there are good examples coming from a bioregional plan that I would like to show, I would like to share with you, that is a transformational pathway to a new civilization that we are proposing from the Amazon, from the sacred headwaters of the Amazon in Ecuador and Peru that are like formed by 30 nations in the Amazon.
Very briefly, I just want to compliment that in these many initiatives in the Amazon, the indigenous people are consulted with what they want. And there are many indigenous groups which are willing, really, you know, we've seen some examples here in her presentation, they are willing to have access to our educational system. They want to learn about technologies. For instance, if you watch this beautiful movie, The Territory, which was launched a few weeks ago here in New York, about indigenous groups in one Brazilian state in the Amazon, Rondônia, you know, they use high-tech drones, they use GPS systems, they use GIS systems, computerized, to monitor illegal deforestation in their indigenous territory. So they're using high-tech to act, you know, in a sustainable way. So yes, we have to consult, but my information so far, many indigenous groups, they want to combine their traditional knowledge with our scientific and technological innovation. It's a challenge, yes, but it's not that we are imposing from the outside our technologies that will destroy their culture. No, they want really to have access to some technologies, to education. So that's why, as I mentioned, the Amazon Institute of Technology, we are going to bring our science and technology with indigenous knowledge all together. And I would say many indigenous populations in the Amazon, they want to have access to technology, but not in a way to destroy the forest, like the monoculture, things like that. Just, you know, in the way they live.
I just want to reinforce the free prior consent. I think that's key. You know, that's a key guideline for any type of action. that has an impact, potential impact in the indigenous group.
Just one final observation. Sorry.
Okay.
I think that's very important in this education system that we respect their culture. In a country like Brazil, that's a big country, we have to develop books and booklets for these people that is not homogenized for the whole country. So for people living in some parts of Brazil, they want to learn what they have around them. I remember discussing with people from São Gabriel da Cachoeira, that is in the north part of the Amazonas state. One of the kids said, the teacher asked me to paint the river, and I painted it in black. And the teacher gave me 0 as a final score. Why? And the kid said, because she wants that I paint the river in the same color of the booklet. That was blue or green. But we don't have blue or green rivers in the Amazon. The rivers are black or are yellow, but not green. So I think that's very important, in other words, to respect the people that live in the countryside and keep them connected with their own culture, with their own environment.
Their language.
There
are some of the languages that are dying, yes.
So we have 10 minutes left. I want to get everybody out of here on time, and I've recognized 2 final questions from this side of the room. So I'm going to ask our panel to try to be brief in our responses.
Thank you for the excellent presentations. My name is Joana Chiavari. I'm with the Brazil's Office of Climate Policy Initiative. I have a question to Professor Nobre. When you presented, you mentioned the green infrastructure, and I was wondering what this green infrastructure would look like, because I'm quite concerned that when we refer to green infrastructure, we might be imagining an infrastructure that does not bring impact, instead of thinking maybe about how to improve the social environmental aspects of current existing transport infrastructure, or thinking about mitigating it. So I don't know if you could enlighten us a little bit. Thank you very much.
Yes, this is a big challenge, of course, sustainable infrastructure, because as we know, particularly the road construction is very associated with deforestation. So we are working on that. I mean, many groups in Amazonian countries are working towards developing green infrastructures. But for instance, the transport potential of fluvial systems in the Amazon is very, very poorly used. So in the 1970s, the governments in the Amazon, mostly starting with the Brazilian government, decided that let's do roads, because that was the development concept in 1970s, 80s, 90s, and even today. So we have really to see ways to improve the natural adaptability fluvial systems, and also fluvial systems based on renewable energy, solar panels, things like that. In fact, I mean, in many parts of the Amazon, and oil, gas, all those things are transported. In Brazilian Amazon, the price of this oil fuels are very high. Brazilians, I don't know how many people know, but we all Brazilians, we pay $1.5 billion of subsidies to transport fossil fuels to the Amazon. And so there is a challenge, but this is a global challenge. More than 70% of global emissions of greenhouse gases is for burning fossil fuels. So this challenge also in the Amazon, how to develop transportation systems based on fluvial systems. This is short range, actually should have been done 100 years ago, but we can do it. We are way behind. But also, as you know, high tech, even things that start to happen here in Europe, Japan, even China, transportation of high added value products by drones. This is going to become the transportation technology in the very near future. This is one of the solutions, and drones that run on renewable energy. So this is another challenge, but why not? It's going to become doable, perhaps in less than 10 years, globally speaking. So we have also to bring this transportation system to the Amazon. Of course, energy, as I mentioned, the potential for renewable energy is in the planet, in the Amazon, a lot. Also, we have green infrastructure have to really make telecommunications, telemedicine available to all populations. This is also something doable today. So this is the green infrastructure. Of course, the main challenge is transportation, but fluvial systems have a tremendous potential in the Amazon. So we should move in that direction very quickly.
Yeah. What are some organizations that are working on the ground to educate people about what's going on in Amazon? It seems rather nefarious. All you hear about is what's happening to the Amazon rather than what can come from the Amazon. Similarly, I don't know where you've been, but colleges and universities in this city, in this country, don't teach much about any of that stuff. I mean, I think maybe at the highest level you can get a degree in some sustainable development, maybe a PhD or a postdoc, but young people need to know about this stuff from the granular level, undergraduate, graduate. I didn't study much about it, but what organizations right now, as we speak, are working on the ground to help people understand what's going on in the Amazon?
It's a tremendous challenge, as I said, all these things are very, very connected, So I think that we have respect the culture of the people. For example, we are talking about Indians, but what about the Ribeirinhos that are not Indians? Many of them moved to the cities. Manaus town now is 2.1 million people. Belém is the same thing. So if you consider that the Brazilian Amazon has a population of 25 million people, 10% of this population is in Manaus, another 10% are in Belém. So I think that technology, education, and environmental conservation are very important in designing interventions in general in the Amazon. So if we have to do something, we have to consider this aspect. And another very important point, I am living in the Amazon for the last 42 years, working for the Brazilian government, and I saw many initiatives in the Amazon bringing or using information produced outside the Amazon. There are tons of examples for that. Some of them are very famous, like the Fordland, like the Humboldt City, like other examples that were initiatives from people that moved to the Amazon to build a new system in the Amazon. And everything, in a few years went wrong and disappeared completely off the system because they did not observe the local characteristics of the system in general. So what I would say is, before anything, we have to observe the local conditions. we have a Brazilian say for that. If you are in the Bahia, you know the Baianos, the Bahia is a state very well known in Brazil, do like them. If you are in the Amazon, do like what the Ribeirinhos do.
Yeah, I'd like to say that if you want to learn more about the conditions in the Amazon and some of the solutions and the policies, there's 3 great summaries, trilingual summaries that are over on this side, as well as a series of policy briefs that emerge directly from 240 different scientists, many of them based in the Amazon or from Amazonian countries. And so this could be the basis. This is something that it's part of an ongoing conversation because this can be part of curricula. This can be part of education to the broader world within and outside of Amazonia. So we have materials right here. They're back there. But there are so many more materials online as part of the science panel for the Amazon.
So unfortunately, we are at time, and I think we're going to have to call it there. Thank you so much, Liliana. We do have materials in the back. You can learn more, and there is still coffee, so if you want to continue this conversation, feel free to stay in the room for a couple more minutes. I think the takeaway today is we have Amazonian solutions, so we have to take them to scale. We have to disseminate what we're doing and implement them in other regions. Thank all of you for joining us. Thank you so much to our illustrious panel. Thank you to all our partners, the Science Panel for the Amazon, the Sustainable Development Solutions Network, and the Science Summit. Thank you to the staff who organized everything today and to Scandinavia House, and I hope everybody has a great weekend.
Choice but surrender.